Greetings, we are Group 11 from BSIT 1A, and we are here for our proposal for the implementation of a security camera network for Excelsa Packet Cafe. Our proposal consists of 5 chapters. Chapter 1 is our feasibility study. Chapter 2 is our data analysis. Chapter 3 is our network design. Chapter 4 is our detailed design documentation. And Chapter 5 being the cost-benefit analysis. I am responsible for handling Chapter 1 and Chapter 2. For Chapter 1, we will discuss the situation and why the project exists. We will also discuss its network scope. We will discuss the objectives of the network and what its goals are. We will discuss the intended users of this network and the design assumptions we made when proposing this network. For our Chapter 2 or data analysis, we will discuss the data types of the network, its data sources, the number of users and their priority levels. We will also discuss storage requirements, reliability requirements, security requirements, and its existing network. Chapter 3 will be handled by Jamil John Andrada, Chapter 4 by Justin Pilongo, and Chapter 5 by Rosana Domingo. Now, this proposal is for a network for connecting CCTV cameras for additional security for a cafe called Excelsa Packet Cafe, as they have requested that they have no security network implemented. This proposal is to be submitted for review towards the owners of the cafe. Now, the proposed network is designed to serve the Excelsa Packet Cafe for its security purposes. Located in Malolos, Bulacan, the floor plan reveals several areas wherein CCTVs could be implemented for the safety and security of its clients. Note that this network is only for security purposes and is specifically designed to monitor the inner workings of the cafe, as well as its employees and customers. Now, this network is designed to achieve several specific business operational objectives. First, the main objective is secure service, and its main purpose is to connect this implemented CCTVs of both sides of the cafe for specific monitoring of the owners and investors of the cafe. It is specifically designed to be isolated from access by those not authorized by the owners or the manufacturers to minimize unauthorized use. Number 2 is it needs to achieve versatile information processing because the network will enable the user or the owners to receive video and audio feedback from the CCTVs. These data shall then be stored into a central hub for data storage purposes as deemed by the client. Lastly, the network is designed for its flexibility in the chance that the client decides to expand the floor plan of the cafe without having to redo the installed network. Of course, the primary users of the network will be the owners, and the manufacturers will be secondary users of the network, for they will receive information from the network and is tasked for maintenance of the equipment and the network, though they will not directly use the network. Now, the design assumes the following. The network built will have a firewall to isolate access towards the users only, and a stable and strong internet service will be reliant upon the owner's cafe. We will now proceed towards Chapter 2. These types of data served by the network will primarily be video-based and audio-based data, as the CCTVs will handle such data and bring it to the network at the end computers of the users. The data will be gathered by the security cameras and will be utilized and can be played back from the end device of the user. The network will not be accessible from the outside, and to access it will require authorization from the client. And there are currently no priority levels as the only users of the system are the owners of the cafe. Therefore, the number of users will be only limited to 2. Storage requirements need to be large enough to store all video and audio data saved by the security cameras. Considering the data load that needs to be stored by the PC, each PC of the user will need a minimum requirement of 50 gigabytes. Each security camera will be equipped with a 32GB SD card to hold more of the data load overall instead of transferring all data towards the NPC. To meet with the expectation of the client and the standards of the industry, the LANs are expected to operate at 99% uptime and a possibly undiscovered error rate of 1%. A firewall will be utilized to prevent unauthorized users from gaining access to the network system. A security measure will be implemented, such as a password and user accounts for authorized personnel. Of course, there is no existing network yet such that it will be built by the company.
Good day, my name is John S. Andrada and I'm here to explain how the top-level network diagram works. But first, let me introduce each legend that is present in this diagram. The first one is the IMO DAWA Cruiser CCTV. The next one is TLSC108 Ethernet Network Switch. Then Lenovo Tower Server, RS Pro Cat6 Ethernet cable, the owner's PC, and lastly, FOC fiber optic cable. So, how does this work? The network is divided into north and south area, 4 CCTVs and 1 network switch for each area. The 4 CCTVs are connected to the network switch using the Cat6 Ethernet cable. The network switch on both areas are connected to another network switch via fiber optic cable. This network switch is connected to the owner's PC and the server to send the data and packets that are received from the CCTVs.
As for the positions of the security cameras, 2 will be placed on the study or work area, 1 will be placed near the restrooms, 1 near the bookshelves, 3 on the social or group seatings, and 1 near the bakery display and order area. For our detailed design documentation, we looked at the various key for lists of the product. We looked at its cost, availability, performance, and maintainability.
IMO DAWA Cruiser is a closed-circuit television that is capable of a built-in mic and speaker, night vision, 2 megapixels camera, motion detection, configurable region, human detection, and two-way audio. TP-Link TLSG108 is a desktop switch hub. It is a gigabit that saves energy, latest innovative, energy efficient technology, greatly expands your network capacity with reliable data transfer, and fanless design ensures quiet operation. Lenovo ThinkServer TS150 is a tower server that has a chipset of Intel C236 platform controller hub, a memory of 8GB 1RX8, PC4 2400E, through DDR4 2400 UDIMM, and integrated Intel HD graphics on Xeon E3-1225 version 6. FOC fiber optic cable has a single core and a length of 1000 meters. RS Pro Cat6 is a Ethernet cable that has a variety of colors, black, blue, and gray. Cables are pre-terminated on both ends with an overmolded RJ45 plug and a high-performance data transmission patch cable. N784-001ST is a media converter with copper ports with a connector type compatibility with RJ45. Envision IP24 version 3 has a screen size of 23.8 inches with 75 Hz refresh rate, 5 milliseconds response time, and 920 1080 Full HD resolution.
I'm Rosana Rose Domingo and I am responsible to the last chapter of this proposal, which I will discuss the cost-benefit analysis, estimated analysis, and lastly, the cost-benefit ratio. For the cost-benefit analysis, we bought the raw materials to produce our proposal for the implementation of security camera network for Excelsa Packet Cafe. During the process of producing the said proposal, we had gathered the prices of each item. To get the sum of this product, we have come up with adding all the prices of all the raw materials together to get the sum of material costs. After that, we multiply the total cost with the quantity needed. And we just find the sum of the materials and gave us the subtotal of tangible cost of 114,882.23 pesos. For intangible costs, we have emergency plans and network issue with amount of 10,000 each, which gave us the subtotal of intangible cost of 20,000 pesos. To get the total of 3 years cost analysis, we just find the sum of subtotal of tangible and intangible costs and gave us the total of 134,882.23 pesos. To get the annualized cost, we just divide the total 3 years cost analysis into 3 years and gave us the total annualized cost of 44,960.74 pesos. And now we will proceed for the second to the last part of this proposal, the estimated analysis. For tangible costs, we have increased productivity with 25,000 per year. Second, increased security with 10,000 per year. Third, decreased anxiety with 5,000 per year. Fourth, decrease the chance of fraud or misconduct with 15,000 per year. And lastly, quality monitoring of high-risk area with 15,000 per year, which gave us the total of 60,000 per year. For intangible product, we have better establishment atmosphere with 5,000 pesos per year. Second, increased staff morale with 5,000 pesos per year, which gave us the total of 10,000 pesos per year. Just need to add the total estimated tangible and intangible products, and it will give us the total amount of 70,000 pesos per year. And lastly, the cost-benefit ratio. We have the total cost with 44,960.74 pesos. Total benefits with 70,000 pesos. To get the ratio, we just need to divide the total cost into total benefits, so that our ratio is 0.64. Therefore, annual benefit exceed annualized costs. To know how long it will take before the project pay for itself, we just need to divide the total benefits into total costs. 70,000 pesos divided by 44,960.74 pesos is equal to 1.56. And we just need to multiply the final answer into 12 so that it will give us the 18 months. So that the project is expected to pay for itself in about 18 months. Therefore, recommended that the project be implemented.